Hello guys, welcome back to my channel. Today we are going to solve some PYQs of MLF 2024. Okay, so the first question is they are asking which of the following 3 metrics have rank 2 with column space equal to row space. Before doing this question, you have to keep one thing in mind that row rank is always equal to column rank, and row rank is dimension of row space. Meanwhile, column rank is dimension of column space. Okay. So in the first option, you can see that it contains for a wait. Before doing this question, rank is equal to the number of non-zero rows. Okay. So as you can see in the first option, there it contains two non-zero rows. So the first option is correct. Second option, after like you have to convert it to REF form. So 1, 2, 3. 2 minus 2 is 0, 4 minus 4 is 0, and 5 minus 6 is minus 1. I have applied R2 is equal to 2 times R2 is equal to R2 minus 2 times R1, and R3 is equal to R3 minus 3 times R1. So now 3 minus 3 is 0, 5 minus 6 is minus 1, and 6 minus 9 is minus 3. If you interchange R2 with R3, you will get 1, 2, 3, 0 minus 1 minus 3, and 0, 0 minus 1. As you can see, it contains 3 non-zero rows. So in this option, the rank will be 3, but we need only rank 2. So this option is incorrect. Third option is also incorrect because it do not contain any non-zero row. So its rank is 0. And fourth option, first and third row is non-zero, so the rank is 2. So this option is also correct. So A and D are correct answers. In the next question, you have given a matrix A as 1, 1, 1, 0, 2, 1, and 0, 0, 3. You need to find a B matrix with the help of A raised to the power 4 minus 3A minus 2I. So first we will find the A square, then we will find A raised to the power 4, and this is your matrix A raised to the power 4. Okay, so we have to find eigenvalues of A, B. What is B? B is the whole expression. Okay, so this is B, wait, sorry. This is B, okay. So as you can see, this is again B matrix. Okay. So there is a property of eigenvalues that the trace of a matrix is the sum of eigenvalues. So what is trace? Trace is 70 plus 8 minus 4, that is 78 minus 4, that is 74. So the trace is 74. And the sum of eigenvalues are 7 plus 8 minus 4, that is also 74. The first option is correct as it is same as the option because the trace of a matrix is equal to the sum of eigenvalues and it matches with the B matrix. Now A has eigenvalues 81, 16 and 1. It is not possible again using the same property. The trace of A is 3 plus 2 plus 1, 6. What is trace? Trace is sum of eigenvalues. So the trace of A is 6 and the sum of eigenvalues are 82, 92 and 98. So that is not equal to 6. So this option is wrong. B is upper triangular matrix. As you can see in this option that the elements below the diagonal element is 0. So B is an upper triangular matrix. B is a lower triangular matrix? No. So option A, comma C is correct answer. Okay. I hope it is clear. Next up is you have given a matrix A is 6, 3, minus 2, 1 and you have given a set. You can do it you can do it on your own. I am erasing this. So we have given a matrix A and set S is V1 and V2. Okay. Now we need to find the given options. Okay. So first we need to find the eigenvalues of A matrix. So using the A minus lambda I is 6 minus lambda, 3 minus 2 and 1 minus lambda is equal to 0. So 6 minus lambda and 1 minus lambda plus 6 is equal to 0. So 6 minus 6 lambda minus lambda plus lambda square plus 6 is equal to 0. Lambda square minus 7 lambda plus 12 is equal to 0. So lambda square minus 5 lambda minus 2 lambda plus 12 is equal to 0. If we take lambda common, then lambda minus 5 minus, if I take 2 common here, so this is lambda minus 6. Okay. Yeah. Mm, this is 6, 6 minus 6 lambda minus lambda plus lambda square plus 6. Okay. So, yeah. So, no, wait. Maybe something wrong here. 6 minus lambda, 1 minus lambda plus 6. So 6 minus lambda into 1 minus lambda minus of minus 6. So that is 6. So 6 minus 6 lambda minus lambda plus lambda square plus 6 is equal to 0. So lambda square minus 7 lambda, I can, wait. So lambda square minus 7 lambda plus 12 equal to 0. So lambda square minus 3 lambda plus 4 lambda, oh wait, minus 4 lambda, sorry. Yeah. Minus 4 lambda plus 12 equal to 0. Lambda into lambda minus 3 minus 4 into lambda minus 3. Lambda minus 3, lambda minus 4 is equal to 0. So the eigenvalues of this matrix are 3, 4. Okay. Now using the eigenvalues, I have to find the eigenvectors. So for finding the eigenvectors, the formula is AB is equal to lambda B. Okay. So 6, 3, minus 2, 1 into, you can say x1, x2. x1, x2 is equal to, what is lambda? Lambda is 3 and x1, x2. So 6x1 plus 3x2 is equal to 3x1 and minus 2x1 plus x2 is equal to 3x2. So in second equation, minus 2x2 is equal to 3x2 minus x2 is x2. This is x1. So wait, minus 2x1 is equal to 3x2 minus x2 is 2x2. So x1 is minus times x2. Okay. Uh, or you can say x2 is minus, or you can say is x2 is minus of x1. So for lambda is equal to 3, we'll get the eigenvectors as x1 and x2. And in place of x2, I can write minus x1. And if I take x1 common, then 1 comma minus 1 is the eigenvalue. So v1 is the eigenvalue. As you can see, 1 comma minus 1 and 1 comma minus 1. Now for lambda is equal to 4. For lambda is equal to 4 x1 x2. Again 6x1 plus 3x2 is equal to 4x1. And minus 2x1 plus x2 is equal to 4x2. Okay. So, yeah, so minus 2x1 is equal to 3x2. And I can say x1 is minus 3 by 2 x2. Okay. Again, for lambda is equal to 4, the eigen vectors will be x1 and x2. And in place of, okay, better to write in terms of x2. x2 is minus 2 by 3 times x1. So, x1 and in place of x2, I can write minus 2 by 3 x1. If I multiply whole with 3, I will get 3 minus 2. Okay. So for lambda is equal to 4, I get the eigenvalue as 3 comma minus 2. Okay. Yeah. So these are our eigenvectors. So F is a set of eigenvectors of A? No, because only V1 is the eigenvector of this matrix A and this does not match with the second eigenvector. So this option is wrong. Only V1 is the eigenvector of A? Yeah, true. Now, in this type of question, I have to solve with the diagonalizable theorem. Okay. What does diagonalizable theorem says? A raised to the power k is equal to P d raised to the power k into P inverse. So if I need to find a raised to the power 50, okay, what were the eigenvalues? Eigenvalue was 3 and 4. Okay. And what is P? P is the column matrix of the eigenvectors. So 1 minus 1 and 3 minus 2. Okay. So okay. So as you can see, as you can see, a raised to the power 50 is equal to, this is P vector. This is d raised to the power 50. What is d? D is the diagonal matrix of including eigenvalues. So 3 raised to the power 50 and 4 raised to the power 50. This is d, and this is the inverse. What is inverse? Inverse is just okay. Inverse is just interchanging the values of diagonal elements like minus 2 and 1 and multiplying with minus 1 to the anti-diagonal elements. So 1 and minus 3. Okay. So this is this, so the third option is matching with our answer. So only B and C are correct answers. Okay. I hope it is clear. Next, move on to next question. Now we have given a matrix A and B. A is the projection matrix. What is the formula for finding the projection matrix? Is A into A transpose divided by A transpose into A. Okay. Projection matrix is A into A transpose divided by A transpose into A. So what is A? A is 1 minus 1 0 and 1 minus 1 0. How many rows and columns? 3 rows, 1 column and 1 row, 3 columns. So the matrix will be 3 cross 3. Divide by, okay, first find A into A transpose. So, 1 into 1. Okay, so wait. 1 into 1. Minus 1 into minus 1, that is also 1. 0 into 0. Okay. Wait. So that is the 3 cross 3 matrix. This is 3 cross 1 and this is a 1 cross 3. So I should get 3 cross 3 matrix. Okay. So 1 into 1. 1 into minus 1, that is minus 1. 1 into 1 is 0 is 0. Minus 1 into 1 is minus 1. Minus 1 into minus 1, 1. And minus 1 into 0 is 0. 0 into 0, 0 into 0 and 0 into 0. This is your projection matrix. If P is symmetric matrix, then P transpose should be equal to P. Let's find the P transpose. 1 minus 1 0, minus 1 1 0 and 0 0 0. So P transpose is as same as P, so P is a symmetric matrix. So the first option is correct. Now projection of B onto A. Projection of B on A can be defined as A transpose B divided by A transpose A into A. What is A transpose B? A transpose B is minus 1. And what is A transpose A? A transpose A is 2 and A. So projection of A on B is, B on A is minus 1 by 2A, not minus 1 by 4 into A. So this is also wrong. P is a one rank matrix. No, P is not a one. Okay, wait. So this is the option, and P is a one rank matrix. So 1 minus 1 0, minus 1 1 0 and 0 0 0. Okay, if I add R2 as R2 plus R1, I will get 1 minus 1 0, 0 0 0 and 0 0 0. So only one non-zero row is there, so P is also a one rank matrix. And plane X is equal to Y is orthogonal to A. What does it mean? Plane X is equal to Y means the Z axis will be 0. So plane X is equal to Y means Z axis will be 0. So Z will be 0 0 0. Now if I multiply this Z with A, 1 minus 1 0. So the dot product will be 0. So I can say that the Z axis is orthogonal to A. So option A, C and D are correct. Okay. Now let's move on to the next questions. Okay. We have to find the least square methods to raise by okay, least square method. So for finding M and C was xy minus summation of x, summation of y divided by n times summation of x square minus summation of x whole square. Okay. What is summation of x into y? Okay, first n is equal to 3. Summation of x into y, 1 into 1 plus 1 into 1 plus minus 1 into 1 minus 1. So this is 1. And summation of x, 1. Summation of y, 3. Summation of x square, 1 plus 3. And summation of x the whole square, that is 1. Now putting into the values n. So 3 into 1 minus 3 divided by 3 into 3 minus 1. So 3 minus 3 is 0. So the value cancel out as 0. So the value of m is 0. Okay. Okay. So if the value of n is 0, then this is wrong. This is wrong. Now the value of c is y summation of y minus m times summation of x divided by n. Okay. What is summation of y? Summation of y is 3 minus m is 0. So this value will be 0. And what is the value of n? N is also 3. So the value is 1. So value of c is 1. So the least, so the best fit line is y dash is equal to mx plus c. As the value of n is 0, so the value will be cancelled out. And what is the value of c? C is 1. So y dash is equal to 1. So option first is correct. Okay. Now what is the error vector? You need to find the error vector. Option first is correct. Error vector is nothing but y minus y dash. What are the values of y? The summation of y minus y dash. So what are the values of y? 1, 1, 1. And what is the value of y dash? Y dash is also 1, 1, 1. Why? Because the best fit line is y dash is equal to 1. So 1 minus 1 is 0 plus 1 minus 1 is 0 plus 1 minus 1 is 0. 0. So the error vector comes out as 0, 0, 0. Okay, so the option A and E. Okay, wait, A, B, C, D, E, F. Okay, so option A, comma F are correct. Okay. Now next question is finite value. Okay. In this question, you just have to differentiate numerator and denominator. So the first option is after differentiating 1 by 3, x is minus 2 by 3 divided by 1 by 2 into x raised to power minus 1 by 2. Now if you put the value x is equal to 1 here, you will see that 1 by 3, 1 by 2. That is 2 by 3. So this is the finite value. So this option is correct. Next option, again minus 1 by 2, x raised to power minus 1 by 2 divided by minus 1. If you put the value x is equal to 1 here, you will see 1 by 2. That is also a finite value. So this is also correct. Now in this question, if you differentiate numerator and denominator, you will get 2x minus 7 divided by 1. If you put in place of x, if you put infinity minus 7 divided by 1, this will give you an infinite value. Infinite value. So okay, we need to find only finite value. So in this option gives you infinite value, so this is the wrong option. Again, in this question, if okay, x square minus a square. If you apply the identity a square minus b square as a minus b into a plus b in the denominator, you will see x square minus a square into x square plus a square. This value will be cancelled out and you will get 1 upon x square plus a square. If you put the value x is equal to a, you will get a square plus a square, that is 1 by 2a square. That is also a finite value. So this is also a correct option. Okay. So the option A, B and D are correct. Now you need to find whether this matrix is diagonalizable or not. So what was the formula for finding the matrix is diagonalizable or not? The matrix A should be written in the form of P, D, P inverse. Or if you take P on the LHS, you will get AP is equal to PD. Now first you should find the eigenvalues and eigenvalues. So eigenvalues and eigenvectors of A. So determinant of A minus lambda I. 2, 0, 0, 0. Okay, wait, sorry. 2 minus lambda 0, 0, 0, 2 minus lambda 1 and 0, 0, 6 minus lambda. If you take the determinant, you will get 2 minus lambda, 2 minus lambda, 6 minus lambda is equal to 0. Okay. Now, the values of lambda will come out as 2 comma 2 comma 2 comma 6. Okay. Wait. The values of lambda are 2 comma 2 comma 6. Now, we need to find the eigenvectors. So what is the formula for finding the eigenvectors? The formula for finding the eigenvectors is AB is equal to lambda B. So what is A? A is 2, 0, 0, 0, 2, 1 and 0, 0, 6 into V. V, what is V? X1, X2, X3. What is the value of lambda? Lambda value 2 and X1, X2, X3. Okay. So 2x1 is equal to 2x1 and 2x2 plus x3 is equal to 2x2 and 6x3 is equal to 2x3. Okay. As you can see, the values of x1, the value of x1 is 0 and same goes with x3. Okay. Or you can do in this way also. You can write a minus lambda I into x is equal to 0. So 2 minus 2 is 0, 0, 0. 0, 2 minus 2 is 0, 1 and 1. 0, 0 and 6 minus 2 is 4. And you will get x1, x2, x3. Okay. So you will get x3 is equal to 0 and 4x3 is equal to 0. Rest x1 and x2 are dependent variable. Now, as you can see, there are two same eigenvalues. So the eigenvector v1 and v2 will also be same. That is 1, 0, 0, comma 0, 1, 0. If someone do not understand this concept, okay, for two dependent matrix, you can say two dependent variables. The basis will be 1 comma 1 0 and 0 1. Okay. Same goes for three dependent matrix. You will see 1 0 0, 0 1 0 and 0 0 1. Here x1 and x2 are dependent variables, so I use 1 comma 0 and 0 comma 1 as a reference, and x3 is independent, so I will write 0 comma 0. Okay. So this is an eigenvector for lambda is equal to 2. Now we need to find the eigenvector for lambda is equal to 6. Again, a minus lambda I is equal to 0. 2 minus 6 is minus 4, 0, 0, 0 minus 4, 1, and 0, 0, 0. And x1, x2, x3. So minus 4 x1 is equal to 0. Minus 4 x2 plus x3 is equal to 0. And there is no x3. So I can write x3 is equal to 4x2 and x1 is 0. Here you can see that x3 is again you can say independent variable. Okay. So for lambda is equal to 6, their eigenvector will be x1, x2, x3. But x1 is 0, so 0. x2 is what? X2 is x2 and in place of x3 you can write 4x2. So your eigenvector will look like 0, 1, 4. Okay. So we got all three eigen vectors. So we'll create a matrix P as 1, 0, 0, 0, 1, 0 and 0, 1, 4. Okay. Now finding whether the matrix is diagonalizable or not. You have to check whether AP is equal to PD or not. Okay. Now if you multiply this with wait, P is 1, 0, 0, 0, 1, 0 and 0, 1, 4. First let's check AP. What is A200, 021 and 006? What is PP is 100, 010 and 014. Now okay, 200, 000, 000, 000, 02, 0, that is 2 into 1 plus 4, 6. This will be again 0, 0, 0, 0, 0, 0 and 0, 0, 24. So this is our AP. Now find PD. What is P? 100, 010 and 014. What is D? D is 226, 000. Now find the product. 2, 0, 0, 0, 0, 0, 0, 2, 0. Wait. 0, 0 and 1 times 6 is 6, 0, 0, 0, 0, 0, 0 and 0, 0. 4 times 6 is 24. So as you can see, AP is equal to PD, so this matrix is diagonalizable. Okay, I hope you understand this question. Now we need to, which among the following models has the least, you can say, misclassification error. Least misclassification error. You just need to put the values of x into sign, and you have to consider sign 0 is 1. So signum of x1 plus x2 plus x3 minus 5. 0 plus 1 plus 2. 0 plus 1 plus 1, 2. 2 minus 5 is minus 3. So this will be minus 1. So minus 1. Okay. 1 minus 5, 1 minus 5 is minus 4. There is minus 1. And 3 plus 1 plus 5, 5 minus 5 is 0. Sin 0 is 1 plus 1. 1 plus 5, 6. 6 minus 5 is 1. So that is also plus 1. 6 minus 5 is plus 1. And 4 plus 1, 5. 5 minus 5 is 0. So that is also plus 1. Here you can see that y and sine functions are all same. So the loss function will be 0. So this first option is itself correct answer. Okay. In this type of question, you just need to put the values of x in signum function and sine 0 is 1 If you have sign negative, then -1, sign positive, then +1. Okay. What is the value of b? In these type of questions, we simply put x is equal to 0. Here you can see x is equal to 0. So if I say minus b upon b plus 1 is equal to b, then minus b divided by b plus 1. If I take LCM, then b plus 1 minus b square minus b is equal to 0, and this will go as 0. So minus b square minus 2b is equal to 0. If I take minus common, then b square plus 2b is equal to 0. If I take b common, then b plus 2 is equal to 0. So from here I get two values, that is b is equal to 0 comma minus 2. And we need to find the value of b, so minus 2 will be your correct answer. In the limit questions, you just need to put the value of x is equal to the given values. Then you can simply find the value, then equate the both values, and then you need to find the values by just you can say solving the equations. Okay. Consider the function f(x). Okay, so first let's find the gradient of x comma y. There will be 2x comma 6y. And if I find the gradient at 1 comma 2, I will get 2 comma 12. Now we need to find the maximum directional derivative occur at point 1 comma 2. So just find the unit vector of your gradient, because we need to find the maximum directional derivative. So 2 comma 12 divided by under root 148. So if you 148 is 2, 7 and 4 to 37. So 2 comma 12 will be your 2 root 37. If you simplify this, then 1 by root 37 comma 8 by root 37. So wait, so this wait, sorry, so this was 12. So this will be your 6. So 1 comma 6. So this will be your correct answer. 1 by root 37 and 6 by root 37. Okay, so linear approximation. What was the equation of linear approximation? The function of the value at a given point plus df upon dx at a comma b into x minus a plus df upon dy at a comma b into y minus b. Okay, and we need to check at the point 0 comma 0. Okay, so let's find it. Find the value at 0 comma 0. So the value at 0 comma 0 will be e raised to the power 0 into cos 0. E raised to the power 0 is 1 and cos 0 is also 1. So this will be your 1. Okay. Then differentiate it with respect to e raised to with respect to x. Df upon dx will be e raised to the power x cos y plus 0. Yeah. So e raised to the power x cos y at 0 comma 0. Yeah. So at 0 comma 0 will be your 1. Then differentiate it with respect to y. You will get minus sine by e raised to the power x. Okay. Now this at 0 now the gradient at 0 comma 0 will be sine 0 is 0. So this will be a 0. Now linear approximation is the value of the function at a given point, that is 1 plus the value the differentiate with respect to x is 1 into x minus 0 plus this is your 0, so I don't need to counter any of this. So 1 plus x. Now we need to find the linear approximation at L of 0.5 comma 0. So in place of x, you simply write 0 comma 5. So you will get 1.5. So your answer is 1.5. Okay. I hope it is clear. Now this is a function fx is 1 plus e raised to the power x, and what is the value of the derivative of fx at x where fx is 1.4. So fx is 1.4. So I can say 1 plus e raised to the power x is 1.4. And if I say e raised to the power x is 1.4 minus 1, that is 0.4. Now the e raised to the power minus x differentiation is nothing but e raised to the power minus x. Okay. So the value at the value of the derivative of f at x is 0.4. You can say it's a very short trick. You just need to subtract 1.4 minus 1. You will get 0.4. Okay. So this is your 2024 set 1 questions. These all are set 2 and 3. You can solve it by your own. If you get any problem, you can rewatch the you can say theory videos. And okay, so yeah, you can do all these type of questions because these all are similar. See, you in this question also you are given a matrix A and you are given two vectors. So simply if you use AB is equal to lambda V, you will get the eigenvalues for V1 and V2. Now, if for finding the for finding the third eigenvector, you can again use AB is equal to lambda V, and in place of V you can put this vector. Okay, then you will get the lambda. Okay. Now these all this sum of all values, and again this you are given a matrix A, be a 3 cross 3 matrix, and if first question is a symmetric matrix or not? A symmetric matrix A transpose should be equal to A. If it is true, then this option will be true. Otherwise, it will be wrong. A is a diagonal matrix. You can see that the diagonal elements are 0, so this is not a diagonal matrix. If A is a symmetric matrix, then A is indeed orthogonally diagonalizable, and then you need to find the eigenvalues of A. Eigenvalues of A, you need to find the determinant A minus lambda I should be equal to 0. So this question also you can do it by your own. This is a theoretical question. You should try it by your own. Again, you are given a vector L, A vector, and you need to find the projection matrix. For finding the projection matrix, you use A into A transpose divided by A transpose into A. You will get a projection matrix. Then you need to check whether P is orthogonally diagonalizable or not. For checking the orthogonally diagonalizable, your matrix should be symmetric matrix. And for checking the symmetric matrix, A transpose should be equal to A. Okay, so after finding the P matrix, you can apply the transpose. If the transpose comes out as same as the original matrix, your matrix will be orthogonally diagonalizable. Then you need to check whether P raised to the power is equal to 4. Again, by using this equation, first find the matrix P, then you can find the power of P, then equate it with the original matrix. Now you are given a matrix B, you need to find the projection of B on the A vector. So the projection of B on A vector will be written as A transpose B divided by A transpose A into A vector. You will solve this by using this you can say formula. And again you need to find the rank of P. So after finding the projection matrix, equate you can say convert it into REF form. Then rank is what? Number of non-zero rows. Again, what to find the best fit line for the data set? Again, you need to find the M and C. How will you find M and C? N times summation of xy minus summation of x summation of y divided by n times summation of x square minus summation of x whole square. For finding C, summation of y minus m into summation of x divided by n. So after applying these two formulas, you will get the values of m and c. Okay, then you will be able to solve this question. Again, okay, so is differentiable at x is equal to 0 if a, b, c, d are constant, which of the following can be true. As I said earlier, just put the value of x equal to 0, so you will get, okay, I can do this question, a plus, so okay. If you put a 0 in place of x, this will be 0, this will be 0, this will be 0. So the value of d will be 1. Okay, the value of b will be done. Then you can do the 2ax plus b is equal to c. If you put x equal to 0 here, you will get b is equal to c. Okay, so b is equal to c and d is equal to 1. Now, next question is, which of the following statements is true for a function f of xy that is differentiable at a point a comma b? If the function is differentiable at a comma b, then the directional derivative exists in every direction. What is directional derivative? Directional derivative is the product of gradient into the unit vector of the like direction vectors. Okay. Which of the following cannot be approximated linearly around x equal to 0? Sin x is 0. This will be your this can be approximated. Cos 0 is 1. This can be approximated. X square at 0 is 0. This can be approximated. But ln 0 is not defined. So ln 0 is like you can say cannot be approximated. So option C is correct. Again, for function, you are given a function, you need to find the gradient vector. The gradient vector will be 2xy, comma 6xy. Okay, these are the gradient vectors. Then you need to put the values here, and you need to find the length of the vector. Yeah, how can you find the length of the vector? Length of the vector is under root of dx square plus y square. Okay. This is a, you can say, case study question. You are given x y. This is basically you can say classification in the you can say supervised learning. Supervised learning classification type. We generally use signum function to find the classification to find the loss function of the classification type. But here is a condition that u of z is 1 if z is equal to 3 greater than equal to 3 or 0. So you can find the z as 0.6 x1 plus 0.3 x2 plus 0.1 x3. Then you can put the values of x1, x2, x3 from this table. If the value is greater than equal to 3, then your value will be 1. And if the value is not greater than equal to 3, then your value will be 0. So from here you can find the loss function. So try it by yourself. Consider a dataset from an e-commerce company such as Flipkart that has the details of customer behavior. Which of the following problems can be best approached using clustering? Clustering is the process of unsupervised learning. Unsupervised learning. Unsupervised learning, the basic work of unsupervised learning is grouping the data. Grouping the data. Okay. Predicting the exact number. No, this is a regression. Classifying customer. This is a classification. Reducing the number. This is also regression. Identifying inherent grouping in customer data. Yes, this is the you can say unsupervised learning clustering process. Again, you are given a matrix. These are 3x3 matrix. Based on the given information, answer the following questions. You need to find the row space. After converting it to ARIA form, the number of non-zero rows will be considered as row space. And after converting it to ARIA form, the column which contains the identity element will consider as a column space. Okay. Okay, so let's do this question. 1, 2, 3. If you add row 2 with row R1, R2 with R1, you will get 0, 0, 0. Then if you perform R3 as 2 times R1, R3 as R3 minus 2 times R1, you will get 2 minus 2 is 0, 5 minus 4 is 1, and 6 minus 6 is 0. So you will get two non-zero equations. So what are two non-zero rows? 1, 2, 3 and 0, 1, 0. So 1, 2, 3 and 0, 1, 0. So this is our correct answer. And You can see column 1 and column 2 contains the identity element, right? Column 1 and column 2 contains the identity element. So for column space, we will consider these two columns: 1 minus 1 2, 2 minus 2 5, 1 minus 1 2, and 2 minus 2 5. So this is your column space. This is your row space. This is your column space. Again, the basic theory behind finding the row space and the column space. First, you need to convert the matrix into row echelon form. The rows which are non-zero in the matrix after converting it to REF form will be considered as your row space, while the column which contains the identity element will be considered as the column space. In the column space, you have to pick the columns from the original matrix, not from the row echelon form. So my 1 minus 1 2 and 2 minus 2 5 is taken from the original matrix. Okay, I hope this is clear. Again, you have given matrix P, you need to matrix A, you need to find the matrix P such that P inverse AP is diagonal and diagonal. So you need to find the P matrix, right? So these all options are P matrices. You can simply put the value of P here. All matrices are 2 cross 2. So for finding the inverse will be very easy. You just need to interchange the diagonal elements and multiply minus 1 to the anti-diagonal elements. Okay. So this will be also done. Which of the following is the best approximation? In this type of question, you don't need to worry about find that formula that Lx is equal to f of x. Nah. You just need to find the under root 4 of 16.1. So 16.1. So what is the under root of 16.1? Wait. Under root of 16.1 is 4.02. Sorry. Under root of 16.1 is 4.012. Now again you need to find the under root of 4.012. Under root of 4. Sorry. Under root of 4.012. Sorry. Under root of 4.012. That will be your 2.00299. So option B is correct. Okay. You just need to find the root 4 of 16.1. Again, the data set you need to find the best fit line. Again, using the same formula, you need to find the m and c. What is the m? N times summation of xy minus summation of x, summation of y, divided by n times summation of x square minus summation of x whole square. For c, again, for finding c, summation of y minus m into summation of x divided by n. Okay. So in this question, I think B is the correct answer. You can find it by your own. In this type of questions, okay, so you are given a gradient of the function x comma y, that is 2x plus 1 comma 2y plus 1. The limit is given as limit x comma y tends to 0 as 5. Okay, find out the directional derivative of function at a point 0 comma 0 in the direction of the vector as 1 comma 1. Then you need to do nothing, like the function at 0 comma 0 will be 1 comma 1. Then the direction of the vectors at the direction of the vectors in the direction of 1 comma 1. So what is directional vector? Directional vector is nothing but the gradient of the vectors at a given point into the unit vector. So 1 comma 1. What is the unit vector of this? 1 by root 2 comma 1 by root 2. So 1 by root 2 plus 1 by root 2, that is 2 by root 2. And if you simplify this, you will get 2 root 2. So, root 2. So root 2 is your correct answer. The following is a supervised learning. Supervised contains 2 types, that is regression and classification. Predicting future skills, regression. Reducing the dimensionality, no, because this is the unsupervised learning, it comes in dimensionality reduction. dimensionality reduction. Recognizing and interpreting handwriting characters or words often used. Yeah, this is also a regression type. And categorizing text documents into the predefined classes such as pen or not. This is the classification type. Classification type. Okay. Now this is the same question which we have covered above. Like this is as same as this one. Question number 2. So do it by your own. Okay. Let A be a symmetric matrix. Okay. A B is symmetric and BA is also symmetric. So there is a property of a transpose matrix. Suppose you need to find the transpose of A into B. So this will be your B transpose into A transpose. Okay. If B transpose is A transpose, then B transpose A transpose should be equal to A into B. Okay, AB equal to BA, then which of the following is for R true? AB is a symmetric matrix. Yeah, because AB is a symmetric matrix. AB whole transpose is B transpose A transpose, and B transpose A transpose is equal to A into B. AB is a symmetric matrix. If AB is a symmetric matrix, it is definitely a orthogonally matrix. And if AB is a symmetric matrix plus AB is a orthogonally diagonalizable matrix, then BA, that is also equal to AB, should have a real eigenvalues. So A, B, and C are correct options. Okay. This is a dimensionality reduction question. Encoder decoder, you have given an encoder decoder pair used for dimensionality reduction where the encoder function is denoted as x1 plus x2 minus x3, x1 plus x2, x3, and the decoder function is u1, u2, u1 plus u2. You simply have to put the points here and you need to find the, see, you have given x, y, you need to find fx, then gx, and you have given a formula also, that is, and you can use this formula, okay. So you can do it by your own. This is a very easy question. And the type of question is, you are given a function mod of x into x minus 2. So if you first you need to find the, wait, yeah, first you need to find whether the limit x tends to 2 plus is equal to limit x tends to 2 minus or not. So function is x into x minus x2, x into x minus 2. So for finding limit x tends to 2 plus, you will write 2 plus h into 2 plus h minus 2. And then h tending to 0, then 2 into 2 minus 2, that is 0. Okay. So limit tends to 2 plus is 0. Same goes with 2 minus, you will write 2 minus h minus 2, you will again get 0. So limit f of x tends to 2 plus and x tends to minus 2 is equal. So the option A is correct. F is differentiable at x equal to 0. You have to keep one thing in mind that the graph of mod function looks like this. This mod function is a special graph where at 0 it is continuous, but not differentiable. Okay. This is a special graph where the function is continuous at x equal to 0 but not differentiable at x equal to 0. So this option is wrong. Then you need to find the f dash of 3 is equal to 4. Then if you multiply x inside, then you will get x square minus 2x. If you find the differentiation, then 2x minus 2 is equal to 0. Then in place of x, you need to find 3. And then 2 into 3 is 6. 6 minus 2 is 4. So this is also correct. F is continuous at x equal to 0. As I have already mentioned, this is a special graph where the function is continuous at x equal to 0 but not differentiable. So A, C, D are correct answers. Okay. So these are all your 2024 quiz 1 questions. I hope this makes your concept more clearer. And yeah. So as I have covered the lectures from week 1 to 4 and I have also covered the PYQs of quiz 1 of 2024 and that is sufficient for this 2025 quiz 1 January attempt. Okay then, that's all. Let's meet in the other next class. maybe after quiz 1, where I will start another playlist that will be for quiz 2. Okay? Till then, goodbye, take care, and all the best for the quiz 1 exam. Okay? Bye bye, take care.